All right, so number 9, you can kind of read over the problem scenario. We have some data, and we're going to go through these 6 parts. So A, scatter diagram between cost and grad rate suggests a positive association between the two variables. We're going to find the least squares regression line treating cost as the explanatory variable. Okay, so here's the scatter diagram. We can see there's a positive and upward trend. We're going to go ahead and find the least squares regression line. So let's do this in Excel. Do you want to do this in Excel? Let's go ahead and do it in StatCrunch. I don't know that we need to see the graph. Let me close it all up. So it says scatter diagram between cost and grad rate. So cost and grad rate, so these 2 columns. We're going to find the least squares regression line treating cost as explanatory. So cost is the explanatory. So we're going to do stat, we're going to do regression, simple linear, x value variable is going to be cost, y is going to be grad rate, and we're going to compute. And so we get our variables here. And what do we want to do? We want to round slope to 6 decimal places and the constant to 3. So we're going to go 6 decimal places here. So we got 0.1230 zeros and then 197, 3 zeros, 197. Okay, 1, 2, 3, 197. All right. As far as the constant, we want to go to 3 decimal places there. So we got 27.411, and that will not go up, 27.411. All right, B says interpret the slope. So the slope says for every increase in the cost by $1, we predict the grad rate to increase by this 0.000197 on average. So the slope shows the graduation rate when the cost is 0. The slope of the least square shows the increase of cost for 1% increased graduation. Cost for every 1% increases the graduation rate. Shows the amount of graduation increases for every $1 increase in cost. Not appropriate. It should say on average. Every increase in $1 would be the more correct explanation. Okay. C, Fisher College private has a 4-year cost of $194,000, graduation rate of 34%. Is this college graduation rate above or below the average for that? So let's look at the data to make sure we're in range. We should be most of the time. I don't think they're going to give us anything that's outside of the range. Can't see the data. Okay, so we have something in the 200, so we got a 194. What is this looking at? 34%. So it gives you the annual graduation rate there. Okay, so let's compute this one and see what we get from our model. So I've got my calculator open now. We're going to do 0.123197 times the cost 194,000, and then we're going to add 27.441 plus 27.4, is that 441,411? Okay, and this gives us a rate of 65%. So we want to round to 2 decimal places, so we get 65.629. The 9 will round that up to 0.63, so 6563. So this amount is going to be below because its graduation rate is less than the average, which is 65.63. D, so we have a scatter diagram between cost and return on investment. We're going to use cost as explanatory variable. There's a negative association between the two variables. Find the least squares regression line. So here's a scatter diagram. Looks like there's just a little clump, but it looks like the downward trend. So you can see the scatter diagram. We're going to do cost and rate of return, or return on investment. And cost is explanatory again. So I think my data is already here. So this time I'm going to do regression line, simple linear, cost explanatory, and then annual rate of return as our y. And then so we get this output. We're going to round slope to 7 decimal places and the constant to 3. So 7 gets much more zeros. 1, 2, 3, 4 zeros, 5, 6, 7, 1, 5, 4, and it's negative. Negative 0.1234, and then our intercept 7.232. All right, so the slope says that every increase in cost is going to go down on the rate of return by about this much. Decrease for every 1%, nope. Shows the amount of return on investment decreases for every $1, yep. Shows it decreases. Okay. And then F, private school, has a return on investment of 3.2%. Is this above or below for 194? Okay, so I'm going to use the new equation now. So I'm going to do a negative 0.1234, 154. That is our slope times the 194,000. Got that same value, yes. 1, 2, 3. And then we're going to add our 0.7232. 7.232, and so we get return on investment as 4.2. They want us to round to 2 decimal places, so we're looking at 4.24. Since this is higher, the predicted is higher, then this amount is lower, is below the average. So this is below the average because its return is less than the average, which is 4.24.